Hey guys, welcome back. This is topic 9, part 6, I believe. So, I kinda added a new example part for solution because I think this one will appear in your test, so I want you guys to be prepared. And it's a good example anyway, so might as well do it, right? So our example that I added is how many liters of pure alcohol must be added to 9 liters of a 85% solution of alcohol to make 91% solution. So before we start filling out the chart, let's talk about what does pure alcohol mean. Well, it means that the alcohol content of that liquid is 100%. So with that in mind, let's start filling up the chart. So we have liters, percent, and total, old solution, pure alcohol, and then our new solution. And then we have 9 liters as shown in the word problem, the given percent. And since pure alcohol is missing, we just simply say it's X. So since all solution and pure alcohol is combined together to make new solution, it's going to be 9 plus X. Now that we know liters and percent, we can find the total, which is shown in this column. So once we get this, we got a new equation, 765 plus 100x is equal to 9 plus x times 91. Simplify things, and you're going to get this new equation. Now we want to, since we have two variables on either sides of the equation, we have to move one of them. And which one do we do? Which one do we move? We move the smaller one by subtraction. So we subtract 91x on both sides, and you're going to get 765 plus 9x is equal to 819. Don't forget to draw the line if you guys want. And then you're going to get 9x is equal to 54. Divide both sides by 9, and you're going to get x is equal to 6 liters of pure alcohol. And that's all you need when you're dealing with that kind of question. So the only difference was we're given this new context on our problem as a pure something. So every time you guys are given pure solution in any solution problem, the percentage of that is going to be 100%. Okay. Now let's move on. This is topic 9, the last part of this topic. And this video main topic, or the main section for this topic, is distance, rate, and time. So suppose you are traveling 3 hours in a constant speed of 30 miles per hour. How far did you travel? Well, not 40 miles. Well, if you travel 30 miles per hour, that means you travel 30 miles per 1 hour, right? In 1 hour, you travel 30 miles, essentially. So we can solve it as 30 plus 30 plus 30, which is 90 miles. Or we can multiply 3 times 30, which will give us 90 miles. And this is what we want. We want from the latter part of how we solve it is that we can see that distance is equal to rate times time. And we're going to need this when we solve distance, rate, time word problems. So we're given, so to solve them, again, we're going to use a chart, and we're going to use these three things, distance, rate, and time, as our columns. So our distance, rate, and time. And then you're going to have some kind of scenario here. A, some kind of scenario here, B, and sometimes you're gonna get total, sometimes you don't need total. Okay, so be careful on that. So let's have an example anyway. So let's say you're jogging and you jog for a while at 5 miles per hour, and then you challenge yourself and you jog at 8 miles per hour. If you ran 7 miles in total in 1.1 hours, how long did you run at each speed? So again, we draw the chart and input the things we know. So distance is miles, rate is miles per hour, time is hours. We have jog 1, jog 2, and total. Total miles and we ran is 7, 1.1 hours, 5 miles per hour in jog 1, 8 miles per hour. But unlike solution or mixture problem, we choose where we put the variable. So in mixture and solution problems, right? You saw that we put variables most of the time or always on the distance in miles, and we just figure out this part, right? But in this distance, rate, and time problems, we're going to choose where we put the variables. Okay, so how do we do that? So how do we even choose? Can we just choose nilly-willy? No, we don't. What we're going to do is you look at the question. How long did you run at each speed? So what are we looking for? Are we looking for distance? Not really. What we're looking for is time. We're looking for how long did you run. So not how much we ran, how long. So we're going to put our variables here. In doing so, we're going to get, and again we're going to be creative because we don't want two variables. So it's going to be t 1.1 minus t on our time. If you want to know the logic behind this, go back on the mixture solution problems because I talked about that. Now that we fill in our rate and time, we can use the distance is equal to rate times time to also know the distance. So it's going to be 5t, and it's going for jog 1, and jog 2 will be 8 times 1.1 minus t. And since we're adding jog 1 and jog 2 to get total, it's going to be 5t plus 8 times 1.1 minus t is equal to 7, and we're going to solve for t. So since we're doing solution, don't forget to draw the line. So draw the line so you know what you're doing, so you don't get confused. If you do one thing on the left side, you do one thing on the right side too. You do the same thing on the right side too. So first thing first, distribute 8 to both terms inside the parentheses, and you're going to get 5t plus 8.8 minus 8t equals 7. Combine like terms, and you're going to get 8.8 minus 3t equals 7. Subtract both sides by 8.8, and you're going to get negative 3t is equal to negative 1.8. Divide both sides by negative 3, and you're going to get t is equal to 0.6 hours in jog 1. But do we stop there? Nope. Why so? Because we want both times on both jogs. Both times on our jogs. So we're going to input 0.6 on our 1.1 minus t to get 0.5 hour in jog 2. Now let's move on to another example. In the morning, Joe takes 170 minutes to walk to school from his home. After school, Joe walks the same road and takes 190 minutes to get home. If his average morning walking speed is 10 meters per minute faster than his average afternoon speed, how far is his home from his school? So first thing first, draw the chart and for all things we know. So morning walk, afternoon walk, total, distance, rate, and time. Time is 170 in our morning, 190 for afternoon. And here we'll have to be creative. So here, his average speed for the morning is 10 minutes 10 meters faster than the afternoon walk. So whatever afternoon is, we add 10 to that. That's why if the afternoon is x, then the morning is x plus 10. In some questions, it's going instead of faster, it might be slower. So what do you do when it's slower? What if instead of it's 10 minutes slower than its average? Is it going to be plus 10? No. What is it going to be then? Going to be minus 10. Things like that, okay? Now, for this word problem, do we need the total part of the chart? Not really, because we're not adding how much he walked throughout the afternoon. So we just cross out the total. And since we know that distance is equal to rate times time, then to get the distance for the morning walk, we simply multiply this and this. And to get the afternoon walk, we simply multiply this and that. Okay? So now here's some critical thinking, right? So when he's walking, since he's walking the same route in the morning and the afternoon, is the distance the same? No, right? He doesn't stop anywhere throughout his walks. He just goes straight from house to school and school to his house, walking the same road. So that means this equation or this expression has to be equal to this expression. Okay? And we can see it right here. X plus 10 times 170 is equal to x times 190. So this is how we can solve for x even if we're not doing the total, okay? That's only given that we're walking the same route. If the word problem doesn't have the same route, then we're pretty much screwed. We cannot do the word problem. But since we're given this leeway, we're able to solve it. Now what we do, we'll just solve for x. So distribute 170 on both terms, and you're going to get 170x plus 17,000 is equal to 190x. Subtract both sides by 170. Oh, don't forget to draw the line. And you're going to subtract by 170x, and you're going to get 1700 is equal to 20x. Divide both sides by 20, and right here your answer is 85 is equal to x. Again, we need to write our unit, and this is 85 meters per minute, and that's our rate of morning walk. Question: ask what does the question ask? Let's go back. How far is his home from his school? So so is this the answer? Nope. So are we done yet? No. So we're going to, how do we find the distance again? To find the distance, we do rate times time. So we're going to get our rate, our concrete rate, not just x plus 10 or just x, to multiply with the minutes that we walk. In this case, what's the minutes is going to be 190. Oh, it's not 170, my bad. So again, be careful on that. Not just Don't just pick any number to multiply with your rate. It has to be the exact minute. So this one's going to be 85. 85 times 190 is 16,150 meters. Now let's talk about the most challenging question, challenge distance. Or we'll just talk about this in the next video. So I want you guys to process this whole video so you guys get confused, and then later we're going to finish distance and we're going to do an extra word problem because this one will appear in your test. And good luck, and this is goodbye.